The last page of the shadow test is about a topic which is new to the GCSE this year, called geometric progressions. Now, geometric progressions are a type of sequence that we used to only see when we got to A level. The only sequences that are covered so far in the current GCSE are arithmetic sequences, where the sequence is going up by the same number each time that we're adding on. Geometric sequences or progressions, we're timesing as we go along. So here you can see that we've timesed by 3 to get 6. We times again by 3 to get 18, and so on. So that's the only difference. We're timesing each time rather than adding or subtracting. And there's two things we need to know about a geometric progression. We need to know its first term, which we give the letter A, and its common ratio, which we give the letter R. Now, the common ratio is just the number we're multiplying by each time. Okay, so the first question asks us to find the common ratio of this progression. Well, we've already shown that it's 3. But if we wanted to show a bit of working to prove that it was 3, we could just divide one term by the previous term. So we could divide the second term by the first term. Okay, or we could divide the third by the second, or so on. Part B, what is the fifth term of the progression? Well, we've got the first, second, the third, and the fourth. Oops, sorry. All we need to do is multiply the fourth one by the common ratio to find the fifth one. So 54 times 3, which is 162. What's the 10th term of the progression? Well, at this point we don't want to keep having to multiply each term by 3 and count on until we get to it. Just like for a normal sequence question, we wouldn't want to keep adding on. We'd want to find the nth term and do it that way. So let's show you how to find the nth term for a geometric progression. First of all, let's write down the first term in terms of A's and R's. Okay, so we know that the first term is 2, but if we're going to write that in terms of A and R, we just use the letter A to represent that. The second term, we know, is 6. How could we write that in terms of A's and R's? Well, it's the first term. It's been multiplied by the common ratio 3, okay, or R, as we're going to call the common ratio. We've multiplied by R. So let's call this AR. The third term is 18. Again, it's just the previous term multiplied by the common ratio. So let's call this AR squared. Okay, and so on. Fourth term, 54. Multiply this by R, which would give us AR cubed. Okay, now we could keep going like this, but the key is to notice some sort of connection between the term number and the formula. Okay, so can you see any connection between this number here and what's going on here? Well, here, look, if we look at this number, we've got 3 and we've got a 2 here. We've got 4 here in the term number and a 3 here. And the fifth one would be AR to the power of 4. Okay, and here actually we could write this R as R to the power of 1. And if you remember that anything to the power of 0 is 1, then we could actually put here that this is AR to the power of 0, because this R to the power of 0 would just be 1, so this would just be A. So you can see that this number here is always 1 less than the term number. So in general, the general formula for a geometric progression, the nth term if you like, is AR to the power of, not n, because it's actually 1 less than n. So we write n minus 1. Okay, so in our case we know that R is 3, we know that A is, first term was 2, so this is 2 times 3 to the power of n minus 1. Now the 10th term, all we need to do is substitute 10 in for n here. So we've got 2 times 3 to the power of 10 minus 1, which is 9. Okay, so we'd have to work out what 3 to the power of 9 is, and then multiply that by 2. And that's not really something you can work out off the top of your head, so this is the only question in the shadow test that you really need a calculator for. So 3 to the power of 9, let's do that in a calculator. That's a very big number. Multiply it by 2. Okay, the answer is 39,366.